Welcome everyone to lesson 3.7 from Precalculus, which is our last lesson on sinusoidal functions, and it's all about context and data modeling. So let's get started. It wouldn't be our last lesson on sinusoidals if it didn't have something to do with regression, but we're going to save the regression for the very end. So let's examine this data and identify some things that we have been able to identify before, just not with random data sets. So if we look here, we go from 0 to 190, so we're looking at a period of 200 x values, or a cycle of 200, if you will. What's happening here? Let's look at the data. So it's going up and then going down. So there's a max somewhere around here. Going down, down, and then up again. So there's a minimum around here. Up, 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 and then down again. So there's a maximum here. Down, down, and then up again. So there's a minimum around here. Up, 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 down, max. Down, 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 up, min, and then we'll keep going up. So it's repeating between it's going max, min, max, min, max, min. The only function we really know to do that is a sinusoidal, and they tell us by default that it's sinusoidal, but if we weren't sure, that's one way to definitely tell. What's going on here? So let's start off with the easier stuff. The period. How long does it take the function to repeat itself? Well, one way to look at period is to look at max to max. One max happens at 80, one max happens at 20, so 80 take away 20 is 60 for our period. And let's see if that continues. Is 60 more than this? That would be 140. That's also a maximum. So that makes sense, right? So the period being 60 makes sense. What is frequency? Well, frequency is equal to 1 divided by our period. So 1/60th is our frequency. Easy peasy, right? Vertical shift. This is a little bit more difficult, right? So when we model sinusoidal functions, we're going to model with the sine function specifically. And the reason why is that our calculator, when it does regressions, is going to use sine. So it only makes sense for us to use something akin to what the calculator is going to use. So we can definitely check ourselves later. So vertical shift, that one actually doesn't matter yet. I'm thinking ahead. Vertical shift, well, we need to find the middle, right? We need to find the middle, and that'll help us with the amplitude as well. Before, we would take the max and the min, we would add them and divide by 2. But look at our values. We have a max of 225, a max of 224, and a max of 227. And we have minimums of 98, 102, 101. So how do we find that? And typically, I'm not going to lie to you, what I would typically do is I would pick the first two and go from there. But if you want something a little bit nicer, something not as mean, let's find the average of the maximums and the average of the minimums and use that instead. So our maximums are 225, our next max is 224, and our next max is 227. Add those together and divide by 3, and we get a max of 225.3 repeating. Minimums, if we do the same thing, we get 98 plus next min is 102 plus next min is 101, and we get 301, divide that by 3, and we get a minimum of 100.3 repeating. Now, the reason I used those numbers is simply because it's not perfect. It's not perfect data. We don't live in a perfect world. Trying to find the average of these is going to help us get a model that is going to work more often. So vertical shift is we're going to add these two things together and then divide by 2. So what I can do is on this calculator, I can go up, enter, plus, up, enter, divide that by 2. And I get a midline, a vertical shift of y equals 162.83 repeating. Amplitude is the opposite. I'm going to take this here, but instead of adding, I'm going to subtract them. So we can go all the way there, change that to subtraction, enter. I get 125 divided by 2, and I get an amplitude, so an amplitude of 62.5. So remember that this is our D value. This is our, like, we'll have to modify that to get the B, but not too bad, not too bad. The last thing we haven't really talked about is the horizontal shift, the phase shift, right? We're thinking in terms of sine. We have some thinking to do because sine goes middle, up, middle, down, middle. We're repeating every 60. So this cycle is going to happen on 15 increments. So think of it as like 0, 15, 30, 45, 60 completes the cycle, right? And sines go middle up. So the max happened at 20. We want 15 before 20. So we want right 5 for sine. So for our sinusoidal function, we're going to have f of x is equal to, amplitude was 62.5. Then we're going to do sine of, and we don't know what the b is, right? But we do know that period is equal to 2 pi divided by b. So if I solve that, I would get b is equal to 2 pi divided by the period. What is 2 pi divided by the period? The period is 60. 2 pi divided by 60 would be pi over 30, right? And then inside that would be x, and we're going right 5, so we're going to subtract 5. And then finally, our midline was 162.83 repeating. So that would be our model for this function. And it's not a perfect model, right? But it's the best we can do by hand, and it's actually a decent model by hand. What we're going to do now is we're going to load the data into our calculator and have the calculator run a sine regression. So I'm going to be back in a little bit, but I'm going to plug all of these values into my calculator into the stat button. So I'll see you soon. Okay, so I have all of these values in my calculator. I'm going to show you some cool things now with this. So first thing I'm going to do is I'm going to go to stat plot. So second stat plot, plot 1. I want list 1, list 2 to be my x and my y. We're going to turn this on, and we want some points. So we're going to see all of these points. If I hit graph, well, that's anticlimactic, right? It's a 10 by 10 graph. What I can actually do, it's cheating, but I can do it. I can hit zoom and then go down here to stat, and it's automatically going to use my lists to create a nice picture where I can see all of my data. Isn't it gorgeous? Now, you can also go to window and adjust these values yourself. Like, it may not make sense to go all the way down to -19 for x. Maybe I can do -10 and then 200, not 100, 200. And it doesn't make sense to increment by 1. Let's increment by 10, because that's what we're doing here. Y's, well, my lowest minimum is like 98, so let's go like 90. Largest maximum was 227. Let's go with like 235. Doesn't make sense to increment that by 1 either, so let's do like 25. If I graph that, I can see a little bit nicer. It's a little bit more exaggerated, but I can see that my data definitely makes some sort of like sinusoidal-esque graph, right? So now let's find the regression. So we're going to hit stat, calc, and then we're going to go to sine reg, one of our last ones here. So sine reg, and we're going to hit enter. And this screen has a little bit more weirdness going on than what we're used to. First, it has iterations. So what this is going to do is, if I'm correct, I may not be correct in this, but what I believe is happening here is that the calculator is going through the calculations multiple times. This iterations is how many times is this calculator going through the calculation. The larger the number, the more accurate the actual regression is going to be. So what's the max number you can plug in? From what I've heard, the max number you can plug in is 16. So let's do that, and that's going to give us the sharpest, nicest one. Our x is list 1, y list 2. That makes sense. Our period, we already found our period to be 60. And we do want to store a regression equation. So before we can go to variables, we can actually use a shortcut, which is alpha F4, and then it gives us a y1. So playing around with the calculator does have its benefits. Let's calculate this and see what happens. It's going to take a little bit because it's doing a lot of work. So there we have it. We have this function here. If I write it down, we can compare. So we have in our model, f of x is equal to 55.604 sine of 0.105. Now, they don't have it factored like we do. So let's not factor it here. X minus 0.48 plus 156.089. So we can see calculator thought differently than we did. Calculator had a different amplitude, had a different midline. What about this? This looks interesting to me. Let's play around with that. What is pi divided by 30? Oh, and something else you're not going to see here is we don't see r squared. It just so happens to be the territory with this one. So, but to find the other, we can do pi divided by 30. I get the same decimal I had before. And that's because we picked a period of 60. We told it the period was 60. So that's why these numbers should be the same. Where'd this number come from? Well, let's distribute. Let's multiply this by -5. Now I can see where that is a little bit. We went right, but we didn't go right 5. We went 5 a little bit less. So that's interesting. What I think this is telling me is that these, even though they are maxes or mins compared to the data around, they're not the true, absolute true, bona fide maximums and minimums of the data. Like it might go a little bit past 225 somewhere in here, is what I believe this is telling me. Now, let's graph. Let's go to our graph. It doesn't go up quite as high, does it? That's interesting. Now, something you might note is you might not have a nice looking graph here. And if you don't, it's because you're in degrees. Look what happens if I change this to degrees and then try graphing it. It's going up and up and up and up. That doesn't look right. Well, remember that 360 degrees is equal to 2 pi radians. So 360 turns into 6.28. It's stretching it out. So let's go back and change it to radians because we deal with radians in pre-calc. And we get this nice curve that does follow along our data decently well. Doesn't go quite up as high as we would like though, but it's the best we can do. There are a lot of applications and there are a lot of interesting questions when it comes to sinusoidal modeling, besides just regression analysis, if you will. And I plan on having a couple of those available for us in class to play around with. So that is it. We're done with sinusoidals for the moment. We're going to move on and talk about other trig functions in the next few lessons, and then polar after that. If you have any questions, please make sure you ask. Otherwise, I'll see you in the next lesson.